What is the role of wildfires in global black carbon emissions? Fires intentionally set by humans, wildfires that spread from human-set fires, as well as accidental fires, are the largest single source of black carbon globally. These fires also release large amounts of CO2 and other greenhouse gases. The record-setting fires in the Arctic Circle this year, especially in the Russian Far East and Siberia, had released as much CO2 by August as Spain does in an entire year. Black carbon emissions from these fires mostly blew north and may have led to complete loss of sea ice in this part of the Arctic Ocean for the first time ever. It's important to note that these Arctic wildfires were almost exclusively human-caused fires, mostly from burning of fields and pastures on forest margins. Indeed, current global emissions estimates of black carbon from fires in the agroforestry sector often underestimate the true scale of human-caused emissions in this sector by focusing only on burning of stubble from 4 major grains alone. The CCAC Agriculture Initiative is working with a variety of actors to better capture all causes of anthropogenic fires in different land types and to promote fire-free alternatives to the different kinds of uses of fire worldwide, because in a warmer and drier climate, these emissions are projected to grow substantially without new and additional measures. What are the best alternatives to fire use in agroforestry? Fire-free methods nearly always exist to replace use of fire in the agricultural sector. Some of these are shown here. In particular, incorporation of biomass into the soil, whether crop stubble, grasses, or forest byproducts, increases soil fertility. In a warmer and drier climate, these technologies and practices also, however, not only avoid risk of wildfire, but increase resilience and adaptation. Burned soils are brittle soils, subject to erosion by wind and water, and requiring greater irrigation as well as 20 to 35% higher fertilizer use. Conservation agriculture, therefore, holds special promise for today's farmers. Part of the CCAC approach has involved showing the benefits of fire-free methods. This demonstration project in Peru intentionally burned part of the field near the local community center, then compared the yields. The farmers could see that the non-burned field had greener and taller corn, and the yields were 30 to 40% higher in the fire-free section. A second successful demonstration with the Punjab Agricultural Institute, PAMEDI, supported farmers to transition to fire-free methods using the happy seeder, which spreads rice and wheat straw rather than burning it prior to planting. The CCAC has a key role in promoting fire-free methods in the agroforestry sector, not only because of the need to reduce health and climate-harming emissions, but also because of the need for greater food security in a warmer and drier climate.